Hi everyone. If you look up at the top of the screen, you're going to see two really long numbers. One deals with a calculation that we'll do based on the energy of electromagnetic radiation down the line. Another one of them deals with basically how many atoms are in little groups that we'll talk about called moles as we get into the middle of the year. But regardless, we have to use these really long numbers. And so I don't know about you, but I don't really feel like writing out numbers that are this long over and over again, right? These things are really big. Or the pink one is actually really small. And so what we do in science is instead of writing out really large or really small numbers, we do something called scientific notation. And you've probably tried scientific notation in other classes, and you may have even memorized a method for doing scientific notation. So I want to try to just give you a method that actually makes sense here in addition to your memorization. So scientific notation looks like this. We end up with one non-zero digit to the left of the decimal point. You'll notice in both of those examples, there's one non-zero digit to the left of the decimal point, and then it's multiplied by 10 raised to some number. And you might have, as I mentioned, memorized something like this, where it says if the decimal point is moved left, the exponent is positive. If the decimal point is moved right, the exponent is negative. And then similarly down here, if the exponent is positive, you can think about what you'd have to move with the decimal point. You move it right. And down here, you'd have to move the decimal point to the left if the exponent is negative. But that's a lot of memorization, right? Left, right, positive, negative, what's going on here? Let's think about what's actually happening. So in this example up top, 2.05 times 10 to the fourth, why does that result from 20,000? Well, what we're trying to do is basically take all of the significant figures from this number. Remember, if we were counting significant figures, we'd say that the 2 is significant, the 5 is significant because they're not 0, this 0 is significant because it's sandwiched, these zeros are not significant because they trail and there's no decimal point. So we need to represent the 2, the 0, and the 5, and remember there's a decimal point after the first non-zero digit. And then we have to multiply that by a number, and we multiply it times 10 raised to a power, right? And so you probably know that you need to count the number you're moving the decimal place, right? And you might be used to doing this. There's 1 way, 2, 3, 4 spots. So you know that your number is either going to be 2.05 times 10 to the fourth, or 2.05 times 10 to the minus fourth. And maybe you memorized which one to go, but maybe you've never really thought about it. Think about what those two things mean. 10 to the fourth power is 10 times 10, which is 100, times 10, which is 1,000, times 10, which is 10,000. 10 to the negative fourth is basically 1 divided by that number, 1 over 10,000. So do you want to multiply 2.05, your number right here, times 10,000? Or do you want to, in essence, divide your number 2.05 by 10,000? Well, if you're looking to get to 20,000, you want to multiply times 10,000. So that's why this becomes 10 to the positive fourth, not negative fourth. The opposite is true down here, right? We have 0.0034. We know the decimal point is moving 3 spots. The question is it positive or negative? Well, if you want to take the number 3.4 and turn it into this decimal, you're not going to multiply it times 10 to the third, which is 1,000. You're going to divide by 1,000 to get this really small decimal, right? So you can think your way through whether the exponent should be positive or negative in order to give you the number that you're after. So for instance, let's do some practice. If you'd like to pause here and try the practice on your own, feel free, and then you can rejoin us. So in 20.3, we know we need to move the decimal place 1 spot. So our number in scientific notation is 2.03. Keep all of those sig figs. And we're going to multiply it times 10 to a power. And we've moved the decimal point 1 spot, so we'd either multiply times 10 to the first power, which is 10, or 10 to the negative first power, which is 1 over 10. Well, we want to make 2.03 become 20, so we're going to multiply times 10 to the first. 2 times 10 is 20. Okay, let's go a little faster. So in the number 1,000, we are moving the decimal point 3 spots, 1, 2, 3. You'll notice that none of those zeros are significant, so really this number is going to be 1 times 10 to the positive third or negative third. Well, it's going to be positive third because we want to multiply by 1,000. Here, we are moving the decimal point 1, 2, 3, 4, 5, 6 times. Write down all of the significant values, so you should have 9.045 times 10 to the 6, or negative 6. Well, do you want to multiply 9 times a million or divide by a million? You want to multiply times a million to get to 9 million. Here we are moving the decimal point 1, 2, 3, 4, 5, 6, 7 spots. We need all of our significant figures, which are 4.56. Remember, all of those leading zeros are not sig figs. Times 10 to the, well, do you want to multiply by 10 to the 7th, which is a really big number, or do you want to divide by 10 to the 7th? Well, you want to divide by 10 to the 7th, right? So that's 10 million that we're dividing by to get that really, really small decimal. 3450, we're going to move the decimal spot 1, 2, 3 places. We're going to write down all of our sig figs, which is 3.45, trailing 0 not significant. We're going to multiply times 10 to the third, which is 1,000. Let's take one little quick time out here, talk about significant figures. So notice in this number, if we just simply wanted to count significant figures, we would count these 3 because they're non-zero. So those are all sig figs. This 0 could be significant, might not be, depending on decimal point. Decimal point is absent. There's no decimal point, therefore that is not significant. So we have 3 significant figures. That's why our scientific notation is written as 3.45. You might wonder, couldn't we write 3.450 times 10 to the third? And that's a good thought, but remember, when you go into scientific notation, the very virtue of scientific notation is that you have a number followed by a decimal point. So you've inserted this decimal point, which means trailing zeros, i.e. this one, is now significant. So all 3 of these are significant. This 0 is significant. This has 4 significant figures. Your number started with 3 significant figures, which is why we have to write this one over here in purple that also has 3 significant figures. So you have to make your significant figures match up in scientific notation. Okay, let's go the other way. Let's expand. Let's take 3.45 times 10 to the 5th. So we're going to write 345, and we are going to move the decimal point 5 spots from here. So there's 1, 2, 3, 4, 5. Let me erase all of those decimal points. Our number ultimately becomes 345,000, which, if you think about it, makes sense, right? Because 10 to the 5th is 10 times 10, which is 100, times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. So 3 times 100,000 gives us 300,000, right? That all makes sense. We're going to move the decimal point the other way here because 10 to the negative 4 means we're multiplying by 1 over 10 to the 4th, or dividing by 10 to the 4th. So now we're going to have 0.0005,003. Again, our sig figs match. 5.42 times 10 to the 4th, we're multiplying times 10,000. So we're going to have 54200. 5 times 10,000 is 50,000. 1.3 times 10 to the minus 9th, I bet you're really happy that we gave you these next two. So we are going to have 0.000000013. You're going to have 8 zeros in there. And finally, 6.022 times 10 to the 23rd. Well, that's the thing that I wrote at the top of the paper to begin with. This ends up being a really crazy long number. Again, enjoy. You are going to have the following. So you are going to have 6022, and then you're going to have an additional 20 zeros after that. If you want to separate with commas, feel free. If you want to just leave it alone, that's fine as well. But that number that we use over and over and over in chemistry is a really good reason why we have scientific notation. Way easier to write out this on the left than it is to write out that over and over and over again.